Hello there. This is Chapter 2, Section 5, Algebra 1, solving equations involving none other than absolute value. So in the first example, we're actually going to start off the section by not solving, but just kind of refreshing your mind with absolute value in general. And so you'll notice that the directions actually, for example, one say to evaluate. And when you evaluate, all it means is that you are plugging in the value that they're giving you for the variable. So in this case, we have absolute value of m plus 6 minus 14 if m equals 4. So we are going to write here absolute value, and instead of m, we're going to put some parentheses there just to indicate that we are going to replace m with 4 in this case, and then we just evaluate what the answer would be. And of course, PEMDAS tells us to stay inside of grouping symbols first. So 4 plus 6 is 10. And then of course, the absolute value of 10 is 10. Subtract 14, and you get negative 4 as our solution. So when m is 4, this expression will simplify to negative 4. So if you wouldn't mind now, you can try do it yourself. Number 1, evaluating this expression for when x is 2. And then we will move on to actually what the lesson is about today, which is actually solving absolute value. And so I have here on the board, what does the absolute value of x equals 4 mean? Another way of phrasing that question is, what are these solutions? That should be a question there. So one of the ways that we can figure this out is to use a number line. So I'm going to go ahead and get me a number line going here. And a lot of you might recall that one of the definitions, or one of the ways that we explain absolute value, is to talk about the distance from 0. So on our number line, we put usually in the center, a 0. And when you say absolute value of x equals 4, what we're really saying is that the distance from 0 is 4 units. So we would go 1, 2, 3, 4, and put a dot right there. 1, 2, 3, 4. And then also, because you can go either direction, you have 1, 2, 3, 4. And then over here. There we go. Sorry, my pen was being very strange. Here we go. Nice and dark. Okay, so if you think about what those values are, you can just use your fingers to count. 1, 2, 3, 4. 1, 2, 3, 4. Negative 4. So what we know is that so what does it mean? It's asking us for the two numbers that are basically 4 units away from 0. 0 being the center in this case. And what we find out is that if we actually solve this equation, then the answers would be x equals negative 4 and positive 4. And if we evaluate, like we just did in example 1, then we would say the absolute value of, let's start with the negative 4. Remember, we replace the variable with what we think it is. What does that equal? The absolute value of negative 4 is positive 4. So in fact, it's a true statement. And obviously, if I use positive 4 over here, those are the two answers, the absolute value of positive 4 is also 4. So when we check our solutions, they actually work. So this is what where we get our basis for how we solve absolute value. Basically, we realize that when you're talking about the distance from 0, there's two directions you could go. You could go to the right or to the left, and you would find potential solutions. In our case, we found two solutions, and they were negative 4 and positive 4. A positive answer and a negative answer. So that's basically how we get to the conclusion that when we solve an equation that involves absolute value, we always have to do what we call two cases. Whenever you solve absolute value, you cannot call yourself done with the question until you have actually solved two separate cases. There are two potential answers whenever you have absolute value. And so in your homework and on your quizzes, if you only do one of the cases, then you'll only get half the points. And generally these questions are worth 6 points, sometimes 8 points apiece. And if you only do one case, then you'll only get 4 out of 8 or 3 out of 6. So you really want to make sure that you do not forget that the main thing for absolute value is that you have to use 2 cases. So we're going to solve one here right now. This is my equation, and based on what we talked about previously, we are going to do a positive case, and we're going to do a negative case. Okay? Now in the positive case, what you do is you take the expression that is inside the bars and you just rewrite it like so. So it's basically the exact same thing as the original without the bars. Okay? But in the case of the negative, you actually put a negative in front of the expression that's inside the absolute value bars. Hence why it's called the negative case. N equals 17. So in the positive case, you just take the bars away. In the negative case, you replace the bars with parentheses and put a negative out in front. Okay? And then you solve like it was a regular equation. You just solve 2 separate equations. So minus 5, and f equals 17 minus 5, which is 12. And then over here, you can divide. You can do it 2 ways. You can either distribute the negative, or you can divide by -1. And I'm going to choose to divide. And then negative divided by negative is positive. So you get f plus 5. But this is no longer positive 17. It's now negative 17. And then you subtract your 5. And you get that f equals negative 22. Okay? And, as we did earlier, you can even evaluate this equation to see if you actually got the right answers by plugging it back in to the original. So if we're claiming that f is 12, if I replace the f with 12, I'm saying absolute value of 12 plus 5, which is equal to the absolute value of 17, which is equal to positive 17, which is in fact what it says it's supposed to be. So that one works. That means that this solution actually works. Then we do negative 22, and do the same thing. We're going to come over here and say the absolute value of negative 22, which is what f is supposed to be, add 5 to that, and negative 22 plus 5 is actually negative 17, but the absolute value of negative 17 is actually positive 17. So again, we see that that's the answer it's supposed to be. So our solutions are accurate, we did it correctly, and we can be happy with that. And then we have to graph our solution. That's the final step. So I'm going to run out of space here, so I'm going to come up here. When you graph your solutions, you don't have to be extremely picky. You have to make sure that you have enough space for your answers. So somewhere over here, I'm going to have a negative 22, maybe a 0, and then maybe a 12. In other words, I always want you to put on your number line the 0. There should always be a 0 on your number line. And what you will see in mine is that the distance from 0, 12 units from 0, is a shorter distance than 22 units from 0. So you'll notice that even though I'm not putting all the individual tick marks along the way, I am aware that 22 is farther away than 12, so this distance is shorter than that distance. And that's pretty much what I'm looking for in your graphs, just to make sure you have a 0 and that these numbers are placed far enough away that you're not misconstruing what's happening. So to solve, to graph the solution set, you want to put a dot at 12, which is right here. That's one solution. And then you want to put a dot at negative 22, which is right there, and that's the second solution. And that is how you graph the solution set for this one. So now I'm going to go on to part B. And part B is actually going to be kind of easy. At least if you're paying attention, it's going to be kind of easy. And the reason is because we do know one thing, that the absolute value, one way of representing absolute value is that it's the distance from 0. And since we understand that distance can never be negative, then, for example, when we're back over here, we don't say that this distance is negative, it's still 4 units away. Then, when you look at part B, it says that the absolute value is equal to negative 3. The absolute value should never be equal to a negative number because the distance from 0, or the distance in general, is never negative. So the fact that this says negative 3, this is an empty set. There is no solution. And we don't even have to continue. because we have it equal to a negative. Now, let me be clear, I'm not suggesting that the answer would never be negative, okay, because we got in the first one, we got negative 22 as an answer. But the absolute value expression should never be equated to a negative number. So that's why this is like not gonna work. So now I'll have you guys try this one, and then we will move on to some of our word problems. And before I get to the word problems, I wanted to show you an easy way that you can remember how to set up the word problems when it comes to absolute value. It's actually not that hard. We want to go back to our number line, and sometimes this is a center, if you will. Everything is kind of color-coded here. So here was, says center. So basically you have two values on the number line. They are A and B. And then you have the center. And here I kind of put the middle here. And you also see these green little brackets up there. And those are basically what we want to call the tolerance. Okay, this is the distance from the center. Distance from center. And that would be both. Both of these are the same thing. They're the distance from the center either direction. And then of course, like I said before, we want to label here, this is the center. The center, the middle between the two numbers that you're dealing with. Okay, so when you have a word problem, every word problem is going to be somewhat different, but there are going to be some key elements. One is there's going to be an unknown. And of course, when we don't know something, that's when we use the variable. So whatever the variable is, it's a part of the question that is unknown to us. Okay, then we have this idea of a center and this idea of tolerance. And tolerance is basically just the distance from the center. For example, we know that if you look at something simple, like earlier we had absolute value of x equals 4, then you could put here for A and B, -4, +4, and the center would be 0. And it doesn't quite look like this, but if you write x minus 0 equals 4, then x is the variable, 0 is the center, and 4 is the tolerance or the distance from the center. That's kind of how that works. But with the word problem, you can even see, for example, let me just give you an example, okay? Let's say that I want to have a fundraiser, and I want to raise $1,000, give or take 25 bucks. Well, the center, okay, refers to the fact that you have a max and a min. You have, I said give or take. So I want to make $1,000, but I'm okay if I make $1,000 or $25 above the 1,000. So it's okay for me to make 1,025. So I said give or take 25 bucks. So also I'm okay if I make 975 bucks. So my maximum is I want to make 1,025. I have no idea why I have a max on how much money I want to make, but to make the problem make sense, we're going to stick to that. But I don't want to make anything less than 975. So I'm okay. I mean, the goal is to make 1,000, but it's give or take $25. Well, that's what we call the tolerance, the give or take. I'm willing to go above or below my ideal by $25. And so another word for center would be ideal or the middle of the values. Okay, so then if I were going to make a word problem for this, then I would say the absolute value of x minus my center, my ideal is 1,000. So I would say variable minus ideal or center should equal the tolerance, which it's not going to equal 1,025. It's going to equal how far from the ideal I'm willing to go. I'm willing to go above 25, below 25. So that's how easy it would be for me to set up this word problem right here. Okay, and I want to show you how, if you want to go backwards, sometimes they want you to go backwards. You're looking at a graph and they want you to find the center and the tolerance. You have two really quick equations here. First of all, we're talking about the max and the min. If you know the max and the min, and we call them A and B, then in my case, it would be the A would be 975 and the B would be 1025. So over here I'm going to put, this is my A, this is my B. Then according to my formula up here, if I want to find the center, which we already know what it is, but I'm just showing you how the formula works so that you can use it in the future. If I want to find the center, then I would add my A and B values. So I would add 975 and 1025 and then divide by 2. Okay? So when I take the 975 and add it to the 1025, I get 2,000. Divide that by 2 and I get 1,000. Okay, which of course we already knew that 1,000 was the center because we had talked about that earlier. So that's 1,000. Then you have an equation over here for how to find the tolerance. And it's equally simple. This time you actually subtract because now you're trying to find the distance between the two numbers. So what you want to do is in this case, take the larger number, the maximum, and that in our case is 1025. So B, subtract A, which is 975, and that gives you 50. So we're going to go 1025 minus 975 and divide by 2. And in our case, 1025 minus 975 is 50. And when you divide 50 by 2, lo and behold, you get 25, which is our tolerance, which is what we had already said earlier, tolerance, okay? So you have a little formula to find center, a little formula to find tolerance, and of course this is always the standard way that you set up a word problem, variable minus the center equal to tolerance. And again, the tolerance can be the distance from the center, it's the give or take, if you will, in the problem, and of course the center is the ideal or the goal in the word problem. So we are going to start here. With an example, says the temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit. So should be. That's the ideal. That's the goal. It should be 80 degrees Fahrenheit. So already we can say that this is our center. Okay? The 80 degrees is our center. And then it says give or take 5 degrees. This is our tolerance. We were talking about that. Give or take. That's the tolerance above and below. This is our tolerance. Find the maximum and minimum temperature. So you set up your absolute value equation. You use a variable for what you don't know, which is the temperature. So that's T. And we subtract the center, which we know is 80. And it equals the tolerance, which we know is 5. Now, you could probably do this problem in your head. You probably already know that the answers are probably going to be 75 and 85. But I want to show you how to set up an absolute value equation to be able to solve this problem. Now we know that when we solve absolute value, we have a positive case and a negative case. And in the positive case, everything stays the same. The absolute value bars get replaced or taken away, like that. And then in the negative case, the absolute value bars get replaced with parentheses, and you put a negative in front. And then we solve this. So we add 80 to both sides, and that's how we get our maximum. The temperature, the max temperature is 85, which again, we could probably already tell by doing it with mental math from the problem itself, 85. Here we're going to divide by the negative, and now we're going to have T minus 80 equals negative 5. When I add 80 to both sides, I now get a temperature of 80 minus 5, which is 75. And again, we had already talked about how the max and the min were going to be between 75 and 85. But I want you to be clear that when it asks you to write an equation, it wants you to write an absolute value equation and then solve it this way as opposed to just doing it in your head. Okay? So, in example, or do yourself number 3, you have an opportunity to do the same thing. Find the center, find the tolerance, and then write your equation. And again, it does say write and solve an equation to find the maximum. So if you just do mental math, it's not going to be enough to get full credit. You need to make sure that you write the equation and solve the equation using the 2 cases. All right, so now we are going to go to our last example, example 4. And this is where we're going to go backwards. This is where that whole center and tolerance is going to be really key for you. Is they're giving us an actual number line, and they want us to write the absolute value equation based on the number line. So what we're going to do first is identify our 2 endpoints, our max and our min, as A and B. And then to find our center, if you recall from the previous slides, to get the center, I am going to add the 2 values together and divide by 2. So I'm going to get 11 plus 19, which is 30. Divide that by 2, and now my center is 15. So right in the middle right here is going to be 15, my center. Now what I need to find is the tolerance. the tolerance is going to be the distance from the center in either direction. So to get the tolerance, again, going back to the formula that we had earlier, I'm going to take the larger value, the B value, which is 19, subtract the minimum value, which is 11, so B minus A, and divide that by 2. So it's not the same thing as center. Center is adding them, tolerance is subtracting them. So 19 minus 11 is 8. Divide by 2, and I get 4. So my tolerance is 4. So you can see here that from 15 to 19, 15, 16, 17, 18, 19 is 4 units. And from 11 to 15, 11, 12, 13, 14, 15 is also 4 units. So you can see that it all works out just fine. So now we get to the part where they actually want us to write the equation out. And so we use a variable. We can use the variable x if it doesn't indicate that we have to use a specific variable. I'm just going to use x. Subtract the center, and the center is 15. And it's equal to the tolerance, which is 4. And so this would be my absolute value equation that represents this graph. So now I'd like you to try this one. And then once you have done that, you will have completed the notes for this lesson. And I will see you in class. Thank you for watching.